All right. Thanks everyone for making it on day 3. I really thought most people wouldn't come here, but thanks a lot for coming. It means a lot. All right. So my name is Vaidyanathan. I'm coming from Bangalore, India, and today I'm going to be talking about the story of how Flipkart.com managed to scale one of the largest MySQL fleets in India on-prem. All right. So very quickly, I'd like to first talk about my employer, which is Flipkart. Flipkart is part of the Walmart group, and it is India's largest e-commerce player. So when we talk a little bit about the stats, we have 400 million registered users in Flipkart. We get about 10 million daily page visits, both on the app as well as on the website. Mainly, it's the app though. And we ship about 8 million shipments every month across the length and breadth of India. It only serves India at this point in time. And all of this is powered by about 100,000 sellers on the platform. So it's pretty massive if you look at it. If you look at the infrastructure that Flipkart has, we have about 22 state-of-the-art warehouses across the length and breadth of India again. And from a data perspective, we have got 3 on-prem data centers, which are modern data centers, and yeah, so that's roughly what the Flipkart group is all about. And then I'll take a few moments to introduce myself. So as I said, my name is Vaidyanathan, but I'm also known as Vaidi here. My son also calls me Vaidi for that matter. And I'm an engineering manager at Flipkart. So for the last 8 years, I've been working in Flipkart, and I currently manage 2 teams in Flipkart. The DBAS team as well as the BCP DR teams, which takes care of all of the disaster management and taking backups, restoration, testing, and all of that. So this is what I manage. And in my journey in Flipkart over the past 8 years, I have been part of multiple teams which are very heavy MySQL users, and also I was managing a couple of teams which were using Vitess. Flipkart as a company has also contributed to Vitess in the open source side of things. Now Vitess is known as PlanetScale, but that's a different story. And I'm also the founding member of Altair, the DBAS product that presenting today, it's called Altair. So I was also the founding member of Altair. And yeah, that's roughly about me. So very quickly, we'll talk about the agenda, what we'll try to cover today. We'll look at the tech landscape of Flipkart. Then we'll talk about the big problem. The big problem shouldn't be very, it should be easily guessable by a lot of you because we are in the database conference, right? We'll talk about what Altair brought to the table, the kind of challenges that we faced in this 2-year journey, 2.5 years journey. We'll stop by to look at some stats about how it's performed and what kind of advantages it has given to the company. Then we'll briefly look at the architecture, the future of the product, how we envision that, and if the time permits, we'll also probably look at a quick demo, and then we'll stop by for a few questions. Okay. Please, stop me anytime if you have any questions, of course. That's just a placeholder, the questions, but you could always stop me anytime you want. All right, so from a tech landscape, Flipkart is a e-commerce company, and at the heart of all e-commerce businesses is actually a very incredibly connected microservices architecture. We have various systems such as order management, logistics, supply chain, seller management, and many other many other subsystems which are there, which are all in a microservice kind of architecture, each talking to each other of sort. And being e-commerce, right, what we typically have is we have very strong consistency requirements. So transactionality is like a very important part of our business, of our tech stack of sort, right? At least for the part where a customer actually pays something to get the order, somebody pays on the app, and the whole journey of that product actually reaching to his doorstep is very transactional in nature, right? We don't want to lose anything out there. So if you look at the tech stacks that are there in Flipkart, a very wide variety of tech stacks power Flipkart and power each of these microservices, and Flipkart typically doesn't really mandate that you have to use this particular tech stack in the entire company or something like that. We are free to use whichever tech stack basically suits the bill, and we get it up and running. And because this is a database conference again, let us quickly look at the overview of databases at Flipkart. MySQL is the most dominant data store in Flipkart, which is used by 70% of all our systems. As I said, because we are very transactional in nature. And if you look at the other data stores that are available, that are being used, that would be Redis, Elasticsearch, HBase, Mongo, and everything else, right? Typically, all the kinds of data stores that we use, all of this is being used today. The hot store transactional footprint itself is easily above 2 petabyte, while the big data, ML, reporting, archival, cold, warm store use cases and all of that have far higher footprints and are beyond the scope of this talk. So continuing on the tech side of things, right, introduction. So we have something called as Flipkart Cloud Platform, which is a on-prem cloud platform that we have in Flipkart. This is very similar to AWS or GCP sort. So we have 3 state-of-the-art on-prem data centers in India. 2 of them are in the city called Chennai, and one of it is in a city called Hyderabad. All of these are southern Indian cities, and these are all latest modern data centers which uses renewable energy. When you look at the hardware, we have customized hardware for mission critical computing, storage, artificial intelligence, ML, and all of it is backed by a very low latency network. When you look at the design, all of the data centers are built for security, scale, elasticity, multi-zone resilience, very high reliability with custom designed racks, intelligent power, and cooling. So we actually own all these 3 data centers and have contributed to the complete design and maintenance of these data centers. When you start looking at the VMs and the choices which are available under the IaaS umbrella, IaaS is instance as a service. So we have different kinds of instance types as you would typically expect in any kind of a cloud provider, which would be compute optimized or memory optimized or storage optimized. We have different ratios as well of memory to compute to memory to storage, and all of that, different kinds of cuts we have. And the typical kind of problems that you see, right, in a data center is that all of this hardware also keeps getting, there are various generations that are there. You start off with a generation, and then over the years you would like to replace that particular, maybe SSDs you would replace, and then you change it to something else. So over time, a lot of these hardware upgrades also keep happening, which means your applications will have to take that into account when you're building all of that. When you look at the storage flavors that we offer today, we have local HDDs, we have SSDs, we have JBODs. Has anyone heard of the term JBODs here? All right. What's the full form? Just a bunch of disks, yeah. So JBODs are there, and then network attached storage is also something that we are exploring right now, because they give far more, they are far more reliable in terms of, and they can scale as well, right? So, and the whole compute storage separation, yeah.
So you're doing local storage for all your VMs?
No, not really. So we use local storage as well as network attached. So all of these we use for the VMs. And it depends on the use case really, right? Like which team wants to use what sort. So we have all these available from a data center perspective. Because I'm coming from the platform side of things, we don't really mandate which storage to use, but then we say that these are all available for you to use, and each team basically decides, depending on the cost associated with what is the price they want to pay for each of these things, they get to choose their storage. And we of course do support custom cuts for very specific use cases, things that do not fit into the traditional VM cuts that we have. There are teams that require extremely high performance. For them, we basically also give them the complete bare metal in case that also needs to be made available. And also, I would like to take a few minutes to talk about Flipkart's journey going ahead as well. We are in a hybrid cloud, multi-cloud journey where we have set up, we have tied up with the Google Cloud Platform to burst into the public cloud. Now you might ask why, right? Because of course it should be a no-brainer that the on-prem data center actually is a better choice in terms of. It makes a lot of economic sense because it's far more cost effective for us. But why the public cloud? The reason is a lot of these e-commerce, I mean, at least in India, we have a sale day which is typically there in the September-October timeframe every year, and the entire year we basically build up for that particular event which is there, and that event you you get tremendous scale, absolutely tremendous scale, and every year it basically keeps, the challenge basically goes up every year over year. This also means what does this mean in terms of latencies and throughputs when they are increasing over and beyond the roof, right? Your hardware also needs to increase that way. You need to have that kind of hardware in your data center, but then you cannot buy all that hardware and keep it for one sale, because you are basically your utilization is very low then. Hence, what we want to do is we want to ensure that the utilization is very high. So we want to use our on-prem data center for the BAU work, but when the sale comes, we want to burst out into the public cloud and then come back out of it. So you just pay for what you use and not really wasting all.
Are you orchestrating that hybrid cloud with something like OpenNebula or OpenStack?
I think we are orchestrating that. So at this point in time, this is a journey, and we have just gotten started on the journey. So that orchestration is going to happen as we speak about. So I might not know the specifics of which technology might be powering that orchestration though. All right. So we'll talk about the big problem, developer productivity. This should again come as no surprise to most of you here, because developer productivity, when I say developer, this is not the SRE, but this is the developer, people who are managing these teams, who are working on these specific things like supply chain or logistics, right? So their productivity was seen to take a major hit, because every team which was using MySQL, and this is the story before Altair came into the picture, right? Majorly needed to invest on developer bandwidth, because somebody had to take a look at the MySQL, and not everyone was comfortable doing that. Best practice adoption was very fragmented across the company. Some teams were using good practices in MySQL, some people weren't, and they weren't sure how to do some of the best practices in MySQL. DB tuning was something which was again very fragmented. Everyone didn't know how to tune a database. It's a very specialized knowledge, right? And not everyone knew that thing.
So everyone was managing their own thing?
So everyone was managing their own thing, yeah. Of course, right? Before DBAS comes into the picture, everyone was managing their own thing, and it was never centralized. So this is the decentralized model that I'm talking about. So none of this should come as a very big surprise. A lot of time gets spent on operations, which is solutioning, setup, maintenance, backup, migration, and there's always an over dependence on MySQL specialists. Every team had to have a MySQL SME, which was very difficult to have. And then finally, there's always this tribal knowledge that gets built in the team, and if that person basically leaves the team, and the team is in a very high risk of sort. There are also big challenges with respect to policy enforcement, which means if you want to enforce a particular policy, if there is a patch version that has a security issue and you want to update that particular thing across the entire fleet in a decentralized model, it's not very easy. You have to have heavy program management to ensure that happens, and it takes far longer to reach the desired state of your security preparedness. So around this time, we started thinking about, Flipkart engineering generally started thinking about the core versus context problem. What this meant is every engineer has two kinds of problems that are there. One is a core problem, one is a contextual problem. So for an engineer who's working in the supply chain landscape, his core problem should be solving supply chain problems and not really worrying about MySQL HA or the reliability of MySQL and stuff like that. So that was how we sort of bifurcated what is a core problem, what's a context problem. And so we wanted to ensure that the platform team that we have here, our core would be to ensure that we build on MySQL and all of these data stores and all of the common technologies that are there, while the teams outside essentially just focus on their business problems. So the product that I'm going to be talking about today is called Altair, and Altair is Flipkart's in-house DBAS solution. DBAS is for MySQL is built on top of the Flipkart cloud platform. It is not yet supported for any other public cloud, but this was solving our problem, so that's why the presentation. It offered a seamless MySQL provisioning, maintenance, and cluster management experience, and abstracted the complete infrastructure provisioning with complete and deep platform service integration. So this systematically solved Flipkart's MySQL challenges, and going forward, we'll see how this was achieved and what kind of challenges came along. Maybe many of you would be able to relate to these challenges, but we'll just talk about these things, right? So first thing is, how do we reduce the overall time to create a MySQL cluster? This was the first problem, right? What was the challenge? Engineers first had to get hardware funded, then create a VM using the command line interface, figure out all the permissions, install MySQL dependent libraries like metrics and all of that. find out what is the process to import data. Not everyone is very comfortable using, for example, MySQL pump, MySQL dump, and a lot of these tools are there, right? Not everyone is very comfortable with these things, and they are mainly relying on documentation, which could definitely be out of date in Flipkart. I mean, documentation typically is out of date everywhere, right? It's never like it's always up to date. It's a challenge to keep it up to date, for that matter. And typically this process took like a day. I heard when I was talking to some other folks in this forum, I learned that some companies even take like a week to provision a database instance. So relatively we were far better, I would say. We used to take about a day or so to provision the database instance, but a day is still too far. So here's what we did. We built a self-serve user interface and pre-provisioned all the accounts, all the teams, all the people, everything there in the whole IAM world and all of that, so that authentication, authorization, everything was pre-built and people already had everything what they needed. We removed the need for infrastructure provisioning, installation, and maintaining MySQL software. Everything was completely under the hood now. People didn't have to actually go and install anything there. It came already installed, pre-installed. So Altair facilitated the project conception to deployment with a target of less than 2 minutes, and to use production grade clusters. So all of these are production grade clusters which are created under 2 minutes, and behind the scenes all of the deep integration was done with the Flipkart cloud services. The second challenge that again we started seeing is that how do we ensure that the adoption is high? People should start using it, right? So while the previous slide was good for new clusters, what about existing clusters? We need to get them under the Altair ambit. So most of Flipkart was using MySQL 5.6 and 5.7, and they feared the move, right? Losing that whole control of their MySQL databases to a different team. What would that team do? We have complete control, and everybody wants that control in life, right? And everybody fears giving away that control to somebody else. And they came up with lots of various reasons of why they would not like to onboard. So here's what we did. We handheld some of the largest teams in Flipkart, largest MySQL teams in Flipkart, and moved them to Altair under the hood. We didn't really, there was no UI built, nothing. We just told them, we'll start taking care of your entire thing. What we also did was we actually moved some of their MySQL SREs into our team. So the teams were really confident that their clusters were still in the same trustworthy hands, right? However, the SREs, they ensured that they weren't doing anything manual. They were actually using the Altair to systemically provision these accounts and migrate them as much as possible. Then we started, in initial days of Altair, what we used to do was we used to be the gatekeeper. We used to ask people, why do you need this kind of instance? You tell me your use case, and let's take a look at your Grafana dashboards and stuff like that. But that gatekeeping was becoming difficult because, the adoption was taking a hit in the pursuit of ensuring that the utilization is high. So what we did was we said, let's stop all of that. Let's onboard whoever wants to come. You just get your stuff over here, and then later, once you're on Altair, then we'll slowly start tightening the screw. But for the time being, we just removed all of the roadblocks. So we started supporting all of the different kinds of storage, which is SSD, HDD, JBODs, direct attachment, everything, all kinds of instance, compute memory instance, everything. Then we also drove an internal program encouraging teams to move their stage NFR dev first. We said that, okay, why don't you move your stage dev and NFR clusters first? And then, if you're convinced about the entire proposal, why don't you move your production grade clusters? And slowly people started moving. Eventually, all of the teams moved their production clusters to Altair, and honestly, they haven't moved out since. All they have done is they have onboarded even more many other production clusters to Altair, and continuously they're onboarding. On a day-to-day basis, we see at least 4 or 5 new clusters that are getting onboarded to Altair.
Yeah. Is this third-party people doing this, or is it your own?
So the way it is done in Flipkart is I'm part of the platform team, and there are various other engineering teams in Flipkart. For example, supply chain team, logistics team, seller world, and all of these things, right? So the culture in Flipkart, at least, is we'd like to see ourselves, each of us, like startups, right? So all of this is internal, but the way I'm talking, it might seem that this is like a startup and I'm trying to get a customer, but that's the mindset we would like to have in the company. Yeah.
Question about the storage choices. Do you see any challenges in terms of supporting different storage choices and the performance characteristics which come with it?
Yeah, definitely, right? No, so yeah, definitely, right. So I think the HDDs, what we have done is we have taken a very, I think you're talking about HDD and SSD. Right, so HDD we have ensured that only warm stores get it, active stores don't get it, hot stores don't get it, right? Hot stores we have mandated that it has to be only SSD, and the compute type instances won't cut it. That is also something clearly called out. The C types won't cut it. It's only going to be the storage classes that will actually work out. So when you're on a warm store, automatically the kind of latency throughput that requirements are there that are definitely lower, and HDD basically makes good sense even from a economical perspective, right? You don't pay too much for that kind of hardware. Yeah.
So when you're trying to onboard these existing customers into this, like when they choose for a specific or a high performance, high capacity, or expensive this one, so how is the billing?
Good question, right? So today we are working on the concept of bring your own hardware. Bring your own hardware. So traditionally in Flipkart, the way we used to have is, every team, every group rather, right, used to have some amount of budget, and using that budget they could get hardware from the central pool of allocations. So they used to own that hardware. So all of these reservations used to, those teams used to have that hardware. So what we started telling people is you need to transfer that hardware from your account to our account, and then once it's in our account, we get complete access, we get SSH access, all of that, and we'll set it up for you. So the construct that we used was bring your own hardware. We did not fund it.
Couple questions. So you said earlier you have many different databases at Flipkart. Is this just MySQL?
This is only MySQL, yeah.
Okay. And do you have the ability to run, say, something on-prem data center, a VM, and then also have something in GCP?
That's the future, yeah. That's what we are building towards, yeah. Because I talked about the hybrid journey, so that is where we are headed right now. Yeah, so I'll cover that in a coming slides.
Master slave, something.
Yes, source replica, yeah. All right, I'll move to the next challenge. The third challenge is how to ensure there are tight security controls, the high security challenge, right? Again, this should come as a no surprise, right? For many teams out here, probably. Teams were using non-secure versions of MySQL, installing scripts on the DB box. This was something which you should never do, but people used to do it all the time. They used to share root credentials openly. There was once, an open joke that, one particular password, a lot of people had even memorized that kind of password. And these kind of bad practices were there about 2 to 3 years back, right? And we wanted to change all of that because this is all a security nightmare if you really think about it. So we wanted to, make sure our security posture is far better. What we did is, this may be slightly controversial to a lot of people, but we completely blocked all of the SSH access for everyone, including the owners of the MySQL clusters. We can do this internally. Maybe we can't do this, if you're a public cloud, but internally we could do this, and we wanted to do this, so we did this. Only the central team had access. We also completely blocked the root @ access. We only ensured that the root @ localhost is available, which means only the people who had sudo SSH permission could actually access the root via the socket. Then we also ran a program where we figured out how to differentiate between human and machine access, because these are two very different things. So we had service accounts for apps, while humans had an approval-based system, RBAC style, for controlled time-bound access to MySQL, that too with a limited privilege set. It's not like everything we used to expose. We also automatically kept rotating all of the user passwords on a predefined schedule, while ensuring machine access was always seamless, because the machine would always know what is the latest password, although users, human users actually had to request for you, and it used to keep changing all the time. So at the end of this, what did we achieve? There were no more spurious scripts or nondescript crons running on MySQL boxes. It was just pure MySQL running on that VM. Only certain limited privileges were now available for MySQL users. Gone were the days where people could get a lot of root kind of accesses. The internal databases were also only accessible by the root. And surprisingly, once people actually came here, nobody has actually complained about losing that access. They were very fearful initially, but then later nobody really complained. Fourth challenge, yeah.
So do you have across the board a standardization of OS kernels?
Yeah, so we typically use Debian 10. Debian 10 is what we use. But then again, as I said, all of the OS also undergoes a maintenance, and we want to upgrade to the latest. So there was a huge program exercise where we moved from Debian 9 to Debian 10, and now from Debian 10 to we'll keep upgrading. That process will always be there.
So as you provision new, that it'll always just be across the board, everybody's using the same OS?
No. So yeah, I understand what you're trying to get to.
How do you kind of mitigate that? Like they want Debian 10, they want Debian 9, they want this kernel, they want how do you?
Yeah, so those flavors will always be available, but unless from a company-wide perspective we say that we are no longer going to support when an EOL happens, right? Typically Debian 9 I think is EOL if I'm not wrong. So when an EOL happens from the community perspective itself, that's when we say that it's no longer supported. But otherwise we do not mandate that everybody has to be exactly on the same version of Debian or on the exact same version of MySQL. All of these flavors would definitely be available, and we also have built upgrade paths for all of these, which means if you want to upgrade your MySQL, there will be a self-serve path, or your Debian, there will be a self-serve path and stuff like that.
Just a question, so you're just running 5.6 or 5.7, you didn't mention 8, or is 8?
We are on the journey to go to 8, yeah.
Okay.
So,
and on multiple, and no MariaDB, so just MySQL.
Yes, it's only MySQL and InnoDB.
So with the different versions, clearly your configuration management has to be version aware with all the...
It's very challenging, yeah.
Yeah.
Absolutely, I completely agree. The fourth challenge was how to ensure disaster recovery and business continuity planning. In other words, this is basically BCP-DR, as many other folks would know. This is basically, this was again a decentralized model in Flipkart where each team had to take care of their BCP-DR planning, which again meant a lot of program management. Not all teams paid close attention to BCP-DR, and in addition, all of this tooling it had to be set up manually via the CLI. What we did, we integrated with that internal tooling using APIs and allowed teams to define their first-class RPOs and RTOs. RPOs and RTOs, I hope everyone knows here, restore point objectives and restore time objectives for the databases, and the tool would, in fact, not just accept any kind of RPO. So, ideally, if I were to ask you what is the RTO would want, everybody would shout 0, right? But that is not a practical answer. If you have terabytes of data, it's not possible to give that kind of a commitment. So the tool also suggests you, depending on your data size, depending on your version, and depending on the hardware and all of that, it actually also suggests you what is the best RPO, RTO that you can get at this point in time.
So you're not running across multiple data centers in parallel all the time?
We are running parallelly across multiple data centers.
Okay. So you're talking about failure of data center or AZ or whatever?
Sorry, I didn't get that.
So you're talking about failures of, for example, an AZ or something like that?
Yeah. The tool also ensured that the backups were taken at a predefined time regularly, and it also supports both the full as well as INCR backups. Then we also built a self-serve way to restore the latest backup on either region. So if you're taking a backup from Chennai, you could be able to, you can easily restore it in Hyderabad. In addition to supporting multi-region MySQL clusters, so we have a single MySQL cluster, logical MySQL cluster that is spanning across multiple regions, and these regions are actually thousands of kilometers apart, in fact. So asynchronous is what works for us. Sync doesn't really work because the latency really is very high when you think about that. We also started regularly tracking the backups. Why we did this? Because of SOX requirements. Again, a lot of you might have worked with these requirements, right? SOX requirements, when they come auditing and all of that, people require us to track these backups, and we started fixing them under the hood systemically. So backups started being pushed to both the near site as well as far site to recover from DC-wide outages, and we use a Ceph data store is what we used to use. Currently, again, we are on the move right now for the object storage solve, right? Like something like S3. We used to use Ceph. Ceph is another open source software for doing that, object storage of sort, and so the backups are also happening from a dedicated backup node instead of reusing the hot standby or the read replica node. So as a result, Schrodinger backups were eliminated. Does anyone know what is Schrodinger backup? Has anyone heard about Schrodinger? Schrodinger's cat? Okay, what does it do?
Is it dead or alive? You don't know until you look at it.
Absolutely, yeah.
It's essentially you're talking about restore testing.
Yeah, absolutely, right? So a backup which you don't test is called a Schrodinger backup, because the state of a backup is unknown unless a restore is performed on it, you would never know what it is. Yeah.
I have a question. So you brought up a topic of SOX and PCI compliance, especially for credit card data,
Yeah.
debit card data. And this is one of the very difficult problems which I also deal with. And how do you ensure in this world where you have multiple teams who are having, do you enforce each of these teams go through that SOX audit and PCI compliance themselves, or the DBAS platform actually provides a framework where the auditors can work with you guys and test out whatever requirements of SOX and PCI compliance are required?
Yeah, I think great question. So even in Flipkart, right, I think not all the teams need to be SOX compliant. There are some teams which have these in scope, right? Like teams which have personally identifiable information, PII data, and all of that, they need to be SOX compliant. But what does it mean? Some of the security controls that I talked about earlier, those are what we have currently in order to ensure that the data is actually secure in a way, and a couple of other controls. So we work closely with the auditors and the team to actually a lot of our requirements actually come from there in terms of what kind of tooling we need to build into the system. So for example, currently we are not PCI DSS compliant yet. Altair is not PCI DSS compliant, which means some of the teams which require PCI DSS in their data stores, we are not onboarding them yet. I'm saying that this is a work in progress. Maybe a month or two down the line we'll have that support. Encryption at rest, encryption in motion, those kind of things. Once we have built that, we'll start onboarding them. So yeah.
So one question. Maybe, okay, so after this I'll ask this.
No, that's fine.
Yeah, so if some teams ask for a 496J or 396J, probably that you think.
Yeah, I'll talk about the high availability.
Okay, yeah.
All right. So how to ensure higher availability? I'll not say complete high availability, right? Because it's also a topic which there are a lot of angles to it. So high availability was one of the most important challenges to solve in Flipkart, and because MySQL could go down at late night sometime, and failover was very manual because the config changes need to be done in the apps, and depending on different technologies, you might actually require an app restart, which means a larger downtime for your services. But here's what we did to solve that problem. See, we built a Zookeeper-based highly available monitoring system that detected failures in a matter of seconds. And what do failures mean? Failures also had to be documented. These are all different kind of failures, for example, and these were deep failure checks, right? It is not just an instance being unreachable, but for a slave, it could mean the replication has been broken, or the disk has reached 90%, or memory has reached a certain threshold, or a lot of these things also are categorized as failures technically, and we have different solves to mitigate all of these things. So what it does is, for example, if you're talking about the source here, if the source fails, we developed the auto promote feature using well-tested recovery workflows that immediately kickstart the recovery process after thorough and deep checks for false positives. There are often false positives which come in. Suppose there's a network blip or there's a network partition that has happened in our control plane, then potentially we might read as something as that it's actually down, but the customer is actually not, the other teams are actually not facing a downtime, so unnecessarily we might do a master failover of sorts. So there is a good amount of deep checks which are happening, including things like, are the slaves receiving updates from the master, or if the master is really down, even the slaves shouldn't be receiving updates, and you shouldn't be able to make any kind of even TCP connection to the master and stuff like that. So unless all of those things are cleared out, we don't really promote it. So yeah.
So when you talk about recovery here, are you talking about database, not database recovery?
Recovery process. Recovery process as in promotion.
You're talking about like say a VM goes down
Yep.
on a node, and it's going to fail over to another node.
Yep.
Is that what you're talking about?
Yeah, I'm talking about that. Yeah, the automated failover. Automated failover is one part, and second, once a failover has happened, HS has become the new master. Now you need to rebuild HS as well, and then rebuild the topology and all of that stuff.
Is your deployment like single primary and multiple secondaries?
Yeah.
Or?
That's right. So we.
Is this handled at the VM level? Is there a VM orchestration as far as failover,
Yep.
or is it just all database?
No, VM orchestration. VM orchestration happens, and now we are slowly moving into the Kubernetes world as well, to see how we can orchestrate that world there. The answer to your question is we have, 3 specific roles are there today, rather 4 specific roles. One is master, of course. We have multiple read replicas, we have a backup node, and we have a designated hot standby. So that's how it is today. And this whole topology we have a primary topology as well as a secondary topology in a different zone altogether. So if the primary completely goes away, the zone completely burns out or disaster or something happens, the secondary zone can actually be promoted and you can still continue. Of course, the writes will be cross DC and stuff like that.
And is this asynchronous or synchronous replication?
This is all asynchronous. Asynchronous. Yeah. Yeah.
So are you guys, you're providing cluster capability, but what about sharding capability? If the requirements exceed that of one master SQL instance?
So there are 2 kinds of shardings, as you would know, right? One is a app-based sharding, one is a DB-based sharding. When you look at DB-based sharding, these are systems like Vitess and many other systems have solved it in their own way. Maybe TiDB has also solved it in its own way, right? But when you look at app-based sharding, then the logic really is at the app layer, right? So you could create multiple clusters in Altair and then have that logic outside of Altair of how you want to use each of these shards.
Have you tried group replication yet on your, or even looked at it on your 5.7 instances, or is your infrastructure not allowed? I know some.
Group replication?
Yeah, it's basically the live cluster so that it auto.
Sync, right? You mean?
Well, it fails over if your primary goes down, the other one fails over automatically, and your customer stuff does.
Yeah, so we are looking at that as well at this point in time. Not many teams have asked for it, so we didn't build it, right? So
The users don't care.
yeah,
The users just want the database to be there and to work and never fail.
absolutely.
We have all our online systems.
Yep. So a lot of it, like as I said, this is driven like a startup, right? Like you try to gather, what is it that teams need out there, and then if this is what they need, we sort of build it for them. So we so far did not get a very strong response to whether people need group replication, and that's the reason why we didn't make it available. But we are going into the distributed side of things. I'll probably cover that later. We also integrated the internal DNS. So we have a DNS system within Flipkart and floating IPs, if you've heard of them, to ensure that the newly promoted source continue to be accessible on the same DNS so that the app restart is also no longer required. What happens because of this is apps needn't be stopped, and you don't need to change any IP address in any configurations, and restarting all of the apps, none of that need to be done. It was just a blip in the traffic if you look at it, and the regular connection retry, it essentially handled the DB failure just fine. Late nights, people didn't have to wake up anymore. Automatically things would get failover and all of that happen. 6th challenge: how to ensure databases are well tuned, right? This because essentially we want to make sure that every team doesn't need to have a SME in their in their team of sort. So this is also one of the challenges you had to solve. So DB tuning is still not a very well understood problem because it needs a lot of specialized knowledge, especially on how to tune the memory configurations. Depending on what kind of workloads you're running, you'll need to keep tuning them, and not everybody knows it very well, right? So here's what we did. We built an in-house variable validation system working on various combinations of about 50 most commonly used variables, and a recommendation system that recommended these values for the tunable, considering both the hardware as well as the MySQL version. Depending on all of that, it would actually give you this. And second thing is, we also set up auto restart for variables which required MySQL restart, and we also separated out these variables both for the source as well as the read replicas. We also posted clear error messages for users who felt just increasing all of the numbers on all of the variables would just mean the performance would increase. That it's a common thing when people do it. So we ensured that the error messages are very clear why you shouldn't just increase your InnoDB to 90% or 100% and just expect things to work magically. And at the same time, we also developed a very small HA, highly available DBA team for tuning very specific and very corner cases. What is the minimum highly available? Can anyone talk about? 2, right? Like one is a main DB and one is the failover DBA. So just a team of 2. That's what highly available means. So it's a very small team, and we wanted to ensure people are available.
Just describe
Yeah. So, as a result of this, teams were far more confident of their database tuning. It was also saved in Altair. All of these configurations, right? The MySQL.conf and all of the configurations were also saved in Altair, so they could just forget about losing them or storing them in Puppet and in their GitHub and stuff like that. They didn't need to do all of that anymore. It was already saved. Seventh challenge: how to ensure good observability despite the lack of root access. Yeah.
Back in the 50 variables and recommendation system.
Yep.
So here the user will type in.
No, it's already pre-populated. It's a page which comes with all of the 50 variables, and the values are also already put in there, right? And if you change any of them, there is also a validation engine that looks at multiple variables and then tells you that this is not a valid number for your valid value for your variable.
Okay. So the reason, I mean, maybe I was trying to understand this way, like saying, okay, if I have a business app which is more transactional heavy, I have this many users, and I need this much of latency. I punch in, this is my requirement. The recommendation system should know, like, this is your CPU, your memory, and this is the storage.
Yep.
And these are the optimization parameters that you should consider. And probably your next step is like it comes with this much of a cost.
Yeah, I hear you, and I think that's what we are working towards. We are working towards a simple mode and a complex mode of sort, or advanced mode. The simple mode, basically you can choose different kind of thing. Is your app write heavy, read heavy, or you need too many connections, or is it very bursty kind of traffic, and all of this. Depending on that, we will configure the rest of the section. But if you want to tune them yourself, you could go to the advanced tab and you could basically do whatever you need to do. Currently only the advanced tab is what is visible, but we are building the simpler view as well.
Yeah, that's the dollar number that people will start with.
Yeah, absolutely. So most of our users are hardcore engineers, right? Typically, so that's why we never faced a problem there, because engineers are expected to understand all of these things, whatever variables they're looking at. So hence, we did not really build that perspective of making it even more simpler. Again, there was no need specifically.
So the database service itself, where does that run?
It's running on the Flipkart cloud platform on a VM on our data centers.
And that's replicated across many different, so if that
Yeah.
VM goes down, it's
Yeah, I'll talk about that as well. I'll probably talk about that as well. There's a different slide for that. Seventh challenge is how to ensure good observability despite the lack of root access. As I said, there is no root access, right? There were no standard deep dashboards across teams for MySQL observability, which are typically powered by metrics that needed root access, something we did not intend to provide to people. Here's what we did. We standardized the dashboard across the organization and integrated with OpenTSDB based internal metric system. And we pre-built deep Grafana dashboards with overall cluster health, member health, MySQL specific, InnoDB specific system network dashboards at a MySQL cluster level. And of course, the benchmark here was PMM. And one of the major reasons why we did not use PMM at that point in time was that internally we weren't using Prometheus as a metric collection source. So I mean that progress, that work is in progress. Once internally we also decide to use Prometheus as the common metric collection source, then PMM will naturally come in. We also pre-created tons of Altair level. So we differentiated alerts into two kinds. One is the kind of alerts that teams need to be aware of. One is the kind of alerts that our team, the central team, needs to be aware of, because alerts always fundamentally need to be actionable. If we give the kind of alerts like memory is going or above limits or something, the client team really couldn't do anything about it. So those are the kind of alerts that don't go to them, but it comes to us. So we created all of these alerts beforehand, and then also integrated it with the team's on-call calendar directly, right? The thresholds were also recommended by us depending on the instance type. The frequencies were also recommended, so people could go and change them, of course. And we also integrated event-based alerting. One is the threshold-based alerting, one is the event-based alerting. And all of that essentially meant that the production grade cluster basically comes up with all of the alerting and everything in place, so you don't really need to worry if something goes down. So we also built auditing and event logging on the cluster. So users could also both download the slow query, error logs, everything directly from the UI. In addition, they could also see what kind of activities have been happening on the MySQL cluster of sort. Eighth challenge, and this was one of the most important things that was there, which pulled a lot of people into Altair, was how to abstract away hardware problems from the user. Hardware abstraction challenges, I'll talk about this, right? Hardware, so when you look at a FCP or a GCP or a AWS, their data centers are extremely vast and extremely huge, right? So everywhere, when you look at failures, they are essentially a probability. Maybe you could say 1% fails or stuff like that, right? At any given point in time. But when your data center is smaller and you have a very large footprint, that means that's how probability works. Your failures are slightly larger, right? So the more space you occupy on a data center, the probability of your failures are a little higher. And which meant that Altair used to have a lot of, people used to have a lot of failures. Essentially VMs going down and people coming to know. But there are two kinds of failures, right? One is essentially scheduled maintenance. One is unscheduled maintenance. Unscheduled maintenance, we can call it as a failure. Scheduled maintenance is something called, that the team is planning to replace a particular hardware of a particular mothership or a rack, and so they are telling you upfront that this is going to go down in the next 5 days or something. So here's what we did. So in Flipkart, all of this information used to come on emails before saying, this particular VM is going down, do something about it. But then that was very difficult to remember, regulate, and reschedule all of that. We integrated with the hardware maintenance schedule API, which is a very low-level data center API. So the Altair system integrated with that kind of API, so we would know beforehand what are the VMs that are going to get affected, and we would mail people. We will actually create something called as internal schedule maintenance. We would create another schedule maintenance top of it. This is the abstraction. So you could do the schedule maintenance anytime before the actual schedule maintenance, the hardware schedule maintenance. So the client could reschedule this in their low traffic hours, maybe sometime in the night, instead of the hardware failing right in the morning. Because even in the data center, people would just do the maintenance in the daytime. Nobody would do it in the night time, right? So which meant services could go down. But now, before they could do that actual activity, the teams would actually come out of that maintenance, come out of that rack or something which was undergoing the maintenance. The question to your the answer to your question, right? So we also ensured that there's a good failure domain in the cluster. Failure domain essentially means multiple failure domains cannot go down at the same time. So if there are, for example, a rack could be a failure domain. All of the motherships inside, all the VMs inside that could be part of a single failure domain. So we always ensure that one logical MySQL cluster always has its at the most basic, the hot standby and the master have to be in different failure domains. They cannot be in the same failure domain. And the best case would be all of the members are in completely different failure domains all of the time. So when that happens, the rate of failure basically comes down drastically.
So this database as a service, all the metadata that it collects for all the VMs across.
Yep.
How is that stored? Is that
Mongo.
MySQL?
Mongo. Now you're happy. Now you're happy, I'm saying. Like the Mongo guys, right? Yeah. So we also build deep health checks to track various hardware problems and replace VMs for unplanned maintenances. Deep health checks, as I talked about, could be various kind of even replication, as I meant, is a deep health check also looks at that. If replication fails, that it will ensure that things are. We'll try to recover what is possible, but in case things are not recoverable after a point, we will just rebuild that particular thing. So teams largely benefited from this feature and gained significant time back on their hands, and the adoption also significantly got boosted. Ninth challenge. Yeah, Fish.
One question. Getting a, losing a VM, losing a server, losing a rack, or losing a data center, so that means you have to take care of 4 layers of different systems. So does that also means that a particular team need a, losing this thing has to be up within short period of time, or whatever that SLA is. So how do you ensure that, meeting those kind of SLAs?
I mean, to be very honest, right?
It's proven to be more difficult for you to ensure that, where you take care of the complete, no single point of failure, but at the same time meeting that SLA to, if it's any customer-facing application.
Yeah. So, for example, now fundamentally, this is a challenge with MySQL asynchronous replication, right? Like, I mean, these are things which, when we look at some of the other things like group replication and stuff like that, right? Or if all of the members are in sync with each other all the time, you take a hit on latency, of course, but then, you know, when one of the source goes down, the other replica is always having the latest data and doesn't really need to wait for all the data to catch up of sort. So when you're in an asynchronous mode of replication, you can never really guarantee what will be the slave lag. Again, the slave lag is broken into the IO lag and the SQL lag. But then, you know, even if the IO lag is completely caught up, the SQL is still mostly single-threaded in order for it to catch up, right? So it will take time, and we cannot really guarantee. If you're asking, is there any bounded number that we say that, you know, within this time, definitely the new hot standby will start serving the writes? Definitely not. We cannot give that guarantee because of the asynchronous mode of replication that is there in 5.6 and 5.7 for that matter. Least, suppose nobody is, I mean, suppose the replication lag is 0 on the hot standby, right? Then we guarantee that it will get promoted within 1.5 minutes, which is 90 seconds. And that was good for most people. Ninth challenge was how to achieve other kind of feature compatibilities without the root access. So teams were using a lot of common features that required the root and elevated access. We had to bridge that gap for successful onboarding without increasing our on-call load. So here's what we did. We built a lot of things around this. We built automatic bin log trimming and bin log streaming for binary logs as well as GTID, so that people could stream their data out of this to Kafka and to something else. Or even the bin log trimming, this is in addition to the options that MySQL gives today in terms of, you know, what is the max bin log retention and all of that. In addition to that, we built some of these things. We also started handling automatic disk divergence between primary and replica. This is a very common problem in MySQL, where the replica typically starts using a lot of more data compared to the primary because of the holes and open holes and stuff like that, which means there is no other way to really solve this problem except rebuild it. I had asked this question in Percona, I mean in the community as well, and the answer that I got is there's no other way around it. You'll have to actually rebuild the entire thing every time it goes into that. This is essentially like, you know, why do you have to keep doing optimized data after some period of time? When you start deleting stuff, you need to optimize your data in order to condense it. So this is typically that problem, and we started doing it automatically. The moment the divergence between the master, the source and the replica goes beyond, say, 10%, then we automatically rebuild it, so it again comes back to the same state as master. We started supporting custom topology, all kinds of topologies you could create in Altair by scaling out both the read replicas as well as, you know, addition CRUD operations you could do on all of the nodes. Basically, you could do HS on backup and do all of that stuff. We also had to build interfaces for CRUD databases because, again, even to create a database you need elevated privilege. So we had to build that as well. Even the users, MySQL users, we had to build an interface to create users, and those users, again, not all the privileges were given, only a subset was given. And we also pre-created stored procedures that allowed viewing debugging information. For example, people might want to find out show process list and kill some queries and stuff like that, which is not possible without elevated privileges. So what we did is we pre-created these stored procedures which were using the root at the rate localhost via the agent, so people could come in and then do it that way without the root access. Then we started supporting upgradation and downgradation of MySQL clusters before the sale events. Migration cutover, along with all of these, basically, has resulted in practically nobody really complaining about the root privileges.
When you say upgrading and downgrading, you mean scaling out and scaling in?
It is scaling up and scaling down.
Yeah.
It is not scaling out.
It's not version changes.
No, it's not. No, version changes are also there. Version changes, GTID migrations, people moving to GTID and out of it, as well as a hardware upgrade and downgrade.
Why would anybody move away from GTID?
No, I'm sorry, moving into GTID.
Right, okay.
Yeah, nobody really moves out of GTID. So quick stats around this. So currently we have about 1,800 virtual machines across Chennai and Hyderabad data center. We have supported almost 500 plus live migrations of existing cluster into Altair, and A2A means Altair to Altair. 300 plus Alto failovers of source, which includes planned as well as unplanned failures of the source node. The footprint is about 1.5 petabyte. The 2 petabyte that I talked about was Flipkart wide. This is what is there in Altair. And we have created about 8,000 plus dashboards, Grafana dashboards. We've handled more than 3,000 failure recoveries, which includes both planned as well as unplanned failures for all kinds of nodes. And then this is currently serving about 600 plus clusters across 128 teams in Flipkart. So all of this is done by a very small 8-member team in Flipkart, which includes the DBS as well as the architect and everything. So this is a combined team of sort.
So most of your clusters are pretty small then, just with
No, they're pretty big as well. They're pretty big as well.
Okay, but the number of replicas is small. Because you've got 1,800 VMs and 600
Yeah.
clusters. So
Yeah,
that's
fair. Yeah.
3 nodes per cluster.
3 nodes per cluster is an average. You're right. You're right.
You covered, so do you support cloning of VMs?
Cloning of VMs as in?
Well, like, let's say I have a development team and they need 100 VMs with a certain version of MySQL and whatnot. How quickly can I do that to provision?
I think bulk provisioning is not something we have built currently. Bulk provisioning of 100 VMs with MySQL, I don't think we have done that.
But what about, like, let's say I'm a development team and I'm working on MySQL and something happens and I want to go back quickly to last week. How quickly can you?
Point in time recoveries?
Yeah, how quickly can you do that? Is it like a database?
No, I think it's very straightforward today. So you can actually, as I said, we have the backup restore and backups are being taken I'll just answer that question, right? And you can actually restore a new cluster using any of using the latest backup. And the latest backup could be even 1 hour old or 2 hours old or anything.
So what I'm getting at is you don't use any snapshot.
We do use snapshots. We have snapshotting.
Hardware.
Software.
Okay, you don't use it.
Yeah. Logical, physical backup.
Well, yeah, I was thinking something that's quick, like hardware snapshot.
Process snapshot.
What's that?
In the storage side, snapshot.
Yeah, exactly. Where you can, like, instantaneously develop.
LVM snapshot's pretty fast too.
Depends on how big.
But so you have very small clusters of like 3 or even 2 machines.
Correct.
And essentially, so that's n plus 2 or n plus 1 redundancy. But if you have n plus 1 redundancy and you have a failure, then you must immediately repair the system because you
Yeah.
have no redundancy at that point. N plus 2, you can do it tomorrow kind of thing, but n plus 1, you really have to jump on it. So do you have automation that rebuilds failed?
So the question is basically the responsibility, right? Whose responsibility is it?
Also, do you assist in having this happen really?
We set those SOPs very clearly, right? So if this is how you have configured your cluster, if people configure just a master for their cluster and going to a sale, then we tell out clearly, right? If this happens, then don't come and ask us, why things are not working, or if things go down, then we are not going to support.
So you offload the decision?
Absolutely, we offload the decision to the.
And so if somebody chooses to run it with just n plus 1,
Yeah, it's their problem. Yeah,
primary,
yeah.
right. And do they have to trigger a recovery if the replica dies?
Yeah, they have to follow the standard on-call process, right? So raise a Jira and stuff like that. So we tell them that if you don't want to get into this headache when actually there's a failure around, then you better prepare yourself beforehand.
You should run n plus 2.
Yeah, you should run n plus 2. Now, a lot of this data is also skewed because a lot of these are test instances, stage instances. That also comes into this, which typically just has a single master instance and it doesn't really have. Yeah.
Fair enough, I'll understand that. Okay, thanks.
Yeah.
So, you talked about the over-the-wire encryption. So, do you do that between client and the MySQL server?
So as I said, we are not yet PCI DSS compliant. I mean, the PCI DSS compliant clusters are not on Altair. They are independently managed outside Altair.
My question is, like, for the compliant cluster, do you do the over-the-wire encryption between client and the server traffic?
I might not actually be aware of that because I'm mainly from the platform team, so I'm not really sure what. I mean, it might depend from team to team really, so I might not be aware of that.
PCI DSS requires it. So
So probably that's, if it requires, we probably must be doing it. As a platform team, I might not be aware if individual teams are doing it at this point in time. Architecture, I can quickly talk about it, but the important thing over here is there is a control plane, there is a REST API, and which are all powered by MongoDB, and there's an orchestrator which is the heart of this entire platform. It supports various things like most of these things are jobs, which means they are asynchronous in nature. We have event loops, we have schedulers, we have multiple recovery workflows, we have an inbuilt state machine to track all of these things. Regular backups keep happening, and cloud integration, alerting engine, auditing engine. So there are multiple such things which are there in Altair. And the monitoring framework, as I talked about, is built on ZK or Zookeeper. And then we have this agent which is running on all of these virtual machines. Yeah, so essentially that's what it is.
Do you have any performance monitoring?
Performance monitoring.
Well, like let's say you know these development teams or whoever's used to a certain quality of service performance with their MySQL cluster or whatever. Do you have any? Does this offer any tools for them to look at that and go, oh yeah, I'm
Dashboards, right? You mean?
yeah.
Yeah. We have a lot of, as I said, we have about 8,000 dashboards that are pre-created. And all of this is built in Golang, and it uses gRPC underneath. So, and Golang is terribly fast, right? Like as many of you might know. What next? From a future perspective, we are going towards the K8 stateful support. That is the work that we are currently doing, and that's where it seems like a lot of the people are actually going in that direction from a Kubernetes perspective. We are building the GCP support, as well as we are working on the compute storage separation at this point in time. In our data center, as I talked about, we have we have the required hardware for making that happen, and now we just got to join the dots in this layer. Open sourcing track, we have started work on open sourcing Altair as an operator on Kubernetes, starting with MySQL. So it'll take some time, but hopefully we'll get there soon. So, and finally on the MySQL side of things, we are looking to support 8.0 sometime soon. Once there is enough, once a community starts asking, community means our community here, what I'm talking about, but once the people start demanding that, we will definitely start building that. We're also looking at semi-sync replication and bidirectional replication. This is something that a lot of people have a lot of, only once I came to this conference, I realized that it's not a great idea. But that is something I'll be taking back from this conference. Yeah.
And the thing is, people think that they can have high reliability, etc., by having co-master, bidirectional replication, and so on. The real answer here is group replication.
Yeah.
Group replication, yeah.
You're right.